Welcome everyone. So this is our 96th live stream geometry, and today I'm going to be doing a bunch of problems from the Iranian Geometry Olympiad. So I've been wanting to do this competition for a while, but the problems weren't released until this week, and so I will work through those. So if you'd like to join us in the future, feel free to email me at mgreenb801@gmail.com. The sessions are on Sundays at 8 a.m. U.S. Central Time. And my email, mgreenb801@gmail.com. It's, I don't know if I already said this, but it's in the description of my video. So I will share my screen. I know today the World Cup's going on, so we might have a little bit of a smaller crowd, but that is okay. So here is the first problem from the competition. I think this is in the hard section. So we have a cyclic quadrilateral with AB equals BC equals CD. How should I do this? Actually, let me do it like this. So I'm gonna have to rename these, but all right. So we'll make this A, B. All right. So AB equals BC equals CD. Why not? I'm just going to call O the center of the circle. And the tangent line at point C intersects the tangent line at A, and the line AB at K and L. All right. So one tangent line, another tangent line. And then we also draw AB. And these 2 points are K and L. So this should be K. And obviously we have KA equals KC. And this is L. And then the circle omega and the circumcircle of triangle KLA intersect again at M. And we want to show that MA is equal to ML. All right. So I'm going to make these look a little better. Like this, like this, like this. And I think that's everything we need. All right. So we have to use somehow AB equals BC equals CD. This looks interesting. I mean, I guess I wonder if all these points are collinear. Yeah. So if we can prove that, I think it might solve the problem. We can, well, it's obvious that K, B, and O are collinear. That's true by symmetry. We have to show that M also lies on that. We know this is an angle bisector by symmetry. If we could show M lies on it, then that would mean M is the midpoint of arc AL, and so we'd have MA equals ML. Okay. So basically, we want to show BCM as a right angle. It's equivalent to that. Which is the same. So showing BCM as a right angle. I wonder if this is the midpoint of AL. It looks like it. I don't know if it's obvious that would have to be true if the problem were true. Let's see. Okay, so let me think about this. Is that obvious that, whoops. Is it, so we could try to show CA equals CL. Is that obvious? Well, CA equals BD, and then BCDL is a parallelogram, right? So I think that proves that, right? So I think we could show CA equals CL, not too hard.
According to me, you can remove M from the problem by trying to prove that BD is parallel to KL.
BD and KL are parallel?
Yeah, so if BD and KL are parallel, then BDA is BMA and KLA is KMA. So KBM would be collinear, and that would imply that angle MKA is MLA and MKL is MAL, which are equal by symmetry.
Yeah. So yeah, if M lies on KB, I think the problem's kind of obvious then, because basically then angle AKM, like you said, is angle MKL. So if they intercept, equal angles intercept equal arcs, and so yeah, MA has to equal
Oh,
ML.
yes, we can remove M by trying to prove that BD is parallel to KL.
Yes. And that's probably just angle chasing, because angle DCL is angle DAC, which is angle DBC, which is angle BDC. So that proves they're parallel. So I think that solves it. Okay, so I think you might have had a different way of thinking about it, though. So with your way of thinking about it, once you prove that they're parallel, what was your idea?
Once they are parallel, BDA is equal to BMA and KLA is KMA. So KBM are collinear.
BDA is BMA, and
KLA is KMA.
oh, okay. So yeah, okay. So that's probably an easier way to see it. So okay. So I'll start by saying let O be the center of omega. Thanks for joining, Hakan. So we have angle LCD is CAD. So angle LCD is angle CAD, which is angle CBD. All right, looks like Khan is joining. And which is angle, so CBD is CDB. All right, thanks for joining, Urijan and Khan. Yeah, we have a good number of people already. So I guess the World Cup didn't stop us. LCD, and so this proves that KL is parallel to BD. And once we know that, then it's really just an angle chase from here, because basically we can show angle DBM is LKM, because DBM. Wait, is that how? I think maybe you should show that. So, sorry, go ahead, Emil.
BDA is BMA.
BDA is BMA.
Angle BDA is BMA and angle KLA is KMA.
Yeah.
Since both
Okay.
angles are equal, KBM should be collinear.
So yeah, so BMA is angle BDA, which is angle KLA, which is angle KMA. So, and this means that KB and M are collinear. And then that basically solves it, because once we know that, then M is the midpoint. So by symmetry, KB is an angle bisector of AKL. So that means Km bisects angle AKL. And that means M is the midpoint of arc AL. And that implies MA equals ML. All right, that was a fun one, nice and easy. Any questions? If not, I will move on. All right, let's try a harder one. So I wonder if this was on the easy or the hard section of the contest. I would hope it would be the easy section. Oh, that was actually on the advanced section. Okay. Well, hopefully the remaining will be longer. Oh, I was thinking of doing mostly IGO problems. Are there any problems that you didn't solve in the contest, or have you solved all of them by now? Yeah. So yeah, they're all going to be IGO problems, unless I could do one non-IGO problem if you'd like, one or two, but that was what I thought of doing originally. Oh, okay. All right. So if you guys already took it, I could try. Let me think. I could try doing some like riddles and middle riddles. But so you said P5 is too hard. Let's see, what was P5? Oh, this one. Okay. All right. Tell you what, I'll do a couple riddles and middle riddles, and then I'll go back to doing the IGO for the people that didn't take it yet. So let's see, what's a good problem? This is a middle riddle, so yeah, it might be a little easier. And there's the reflection of M over AI. This is kind of interesting. Oh, the Euler line of triangle DEF. That's probably really hard, actually. Well, but it's only a middle riddle. This one looks kind of interesting. I'll do this one. Maximize it. I forgot what number it was. Middle riddle, Discord. Okay, so we have a triangle ABC with in the center I. Okay, P5. All right. So the in circle has center I. BI and CI are the theta angle bisectors. Okay, so let's draw those E and F. and EF intersects the circumcircled ABC at 2 points, X and Y. All right. Yeah, the taller the triangle I make, E and F kind of look best. See, if I make it a tall triangle, it almost looks like the tangency point. So what if I make it a triangle like this? I think that looks maybe okay. So X and Y. Oh, but I don't know which one is X and which one is Y. So let me check. I think this should be Y. And this should be X. I think that's what the problem looked like originally. So if R1 is the radius of IBY and R2 is the radius of ICX, then we want to show that IB over IC is R1 over R2. Okay. It's interesting. So we have this, this, and this. So IB over IC, we kind of know what that is in terms of like the angles of triangle ABC. So sine of B over 2 is IB over IB, and sine of C over 2 is IB over IC. So this is really sine B over 2 over sine C over 2, or maybe the other way around. And we want to show that that's the ratio of the radii of these circles. Let me see if those circles intersect somewhere important. I don't think so. All right. Hold on one moment, guys. I'll be right back. All right. Got myself a little snack. Yeah, this is always tricky when you have like a line connecting the feet of the angle bisectors. Like I don't know how to use that. Maybe it's worth letting X, Y, and BC meet at a point. Then at least maybe we could use like harmonic conjugation or something like that. Let me first think about how I would use that. So if IB equals IC, sorry, go ahead.
We can also relate radius to the sine law in these triangles.
Okay.
So 2r is equal to a by sine a, right?
Yeah.
So the r1 can be related to bf or bi, and it also involves angle b by 2. No,
I mean,
it
basically
yes,
this
it can be related to bi, right?
like this condition, I think another way of saying what you're saying is that like that means that BI and CI are like similar parts of these two circles, right? So it's like angle BYI should equal angle C. I think it's the same thing. Angle BYI is angle CXI. Let me check if that's true.
Yeah, yes.
Yeah. So yeah, if we can show that, that's equivalent to the problem. All right.
Yes.
So yeah, interesting. So we want to show BYI equals CXI. I wonder if these two triangles here are similar. So FIY and EXI. No, they're not similar. All right. So I wonder if I could highlight an angle without giving it size. Let's see. I could highlight a polygon. Actually, I think I could just say like don't show degrees or something. Um, if I just say name, and then I do the same with this. Show the name. Then we want to show alpha equals beta, and that would solve the problem. But those triangles aren't similar necessarily, I don't think. So, sorry. So IBY and let's see, XCI. Yes, they're not similar triangles, but we want to show those angles are equal. All right. Wonder if it's worth drawing these 2 points. Let's see. Yeah, I don't even know how important the end circle really is. I'll leave it there. IG equal IH? No. Okay, I'm going to delete those points. Well, I guess it's kind of like saying, okay, so this actually looks good. So if we label this point and this point right there, basically we want to show that AHIG is a kite. Because if we show AHIG as a kite, then that would mean angle IHB is angle IGC, and from there we'd have alpha equals beta. All right. Since we know AI is at an angle bisector. Interesting. Okay. So yeah, I wonder if we can like work backwards. Like, can we construct points H and G first somehow? And then based on that, show that X and Y lie on EF? Okay, so yeah, we want to show if we could show IH equals IG, that solves the problem. And IH is intercepted by an angle of B over 2. Are there any congruent triangles? So HI, okay, so we want to show, or we can equivalently show AH equals AG. That would also solve it. So we know, yeah, so the power of A with respect to this circle is AH times AB, and the power of A with respect to this circle is AG times AC. If we can show the ratio of those powers is AB over AC, then that would solve the problem. Because then we'd have AH equals AG. That would mean these triangles are congruent, and everything would work from there. So I wonder, I was thinking about like the power ratio lemma. Wonder if there's anything special about this circle. No, I don't think so. I mean, maybe, but let's see. It's the polar. I don't think there's anything special about that. Yeah, what if I draw AX and AY? So for example, first AX. So that would then AJ times AX is the power of A. Hmm. So I want to calculate the ratio of the powers of A with respect to both these circles. Show it's AB over AC. Yeah, I'm like trying to find the right line through these circles. Let me try this. I don't think it's that one. Maybe just the angle bisector, see where it meets both circles. Looks like these concur, but that shouldn't be true. So basically, I want to show AJ, if I could show AJ over AK is AB over AC, that would also solve the problem. I wonder if AJB and AKC are similar. I think they would have to be in that case, right? Yeah. So if we could show AJB equals AKC, or similar to AKC, then that solves it. Let me just check it, but I'm pretty sure that's true. Yes. Okay, so we want to show triangles ABJ and ACK are similar. It's weird. It looks like angle ACK is bigger than ABJ, doesn't it? But I thought I just measured it and showed it's not true. So let's see. ACK. This looks like bigger. Wait a sec. That's only 33.9 degrees. Huh. Must be an optical illusion. It looks like that's bigger than this. I must just have bad eyes. Doesn't this look? I guess they're the same. Yeah. Okay. So angle HBJ. Let's see. It's HIJ. Yeah, we don't really need H and G if we're doing it this way. So BYI is BJI. And then CXI is 180 minus CKI. So yeah, we could, what if we drew the midpoint of this arc? Then, basically we want to show angle LKC is angle LJB. And we know LC equals LB. So this equals this, and we want to show that angle LKC is LJB. So we want to show that these certain circles are actually of the same size, LKC and LJB. I wonder if they're congruent. Let's think about that. I'm not sure they're actually congruent, but that were true, then we want to show that this equals this. I'm not sure that's, yeah, that's not true. Okay. So we could show that this and this have the same size circumcircle. That would solve the problem. If that were true, I don't know if I'm making this easier or harder than it is originally. But yeah, if these circumcircles have the same size, I would think, oops, sorry. I would think their radical axis should be the perpendicular bisector of BC. So I would think, if I draw the perpendicular bisector, yes, okay. So another way we could do it is we could show, if we draw this, if we label the center of this circle, we call it O. If we can show that O has the same power with respect to this circle and this circle, that would solve it. A lot of equivalent things, but I'm not sure how easy any of them really are. Or if we could show the midpoint of BC has the same power with respect to both of them. I don't think these concur. Yeah. Interesting. Yeah, I have no idea whether I'm making the problem harder or easier or what, but this is just what I've thought so far. Circle IXY passes through the B and CX centers. Okay. Let's see. So I'll try to do what both of you said. So circle IXY passes through the B and CX centers. That seems kind of important. Okay. Can I try extending BI? Okay. All right. So let's draw these points and then use the in-center X-center lemma. So I'm going to want to, let's see. Okay. So you're saying that this point is the BX center and this point is the CX center. Let's think about that. So that would mean that Oh, sorry, I don't want point X, I want this point. Interesting. Okay. So this, call them what are some good letters? U and V, why not? It follows by power of a point through EMF. Okay. Hold on just one sec. Let me make the diagram look better. So yeah, I'm gonna erase some of the other stuff I did with points J and K. I think that just might make it more confusing. I'll leave what you mentioned. Because yeah, that seems pretty important. If those are the X centers. Okay, so power of a point through E. Basically, by the in-center X-center lemma, if we could show that XU equals, sorry, not XU. I want to draw these points too. If we could show that JA equals JU equals JI equals JC, that would prove it. So we have JU times JI. Well, you're saying a power of a point through E. So, what do you think? How does that work? So, EX times EY is EI times EU. And that, we want to show that's basically 2JI squared. So EI times EU. So I'm still trying to understand how it follows. So basically, we want to show EI times EU. Yeah, how does it work? So EA times EC. Okay, EA times EC is EY times EX is EI. So I think you're saying like this is a cyclic quad by power of a point? Yeah. And then this is 2. And so from there, we know J has to be the center of it because J is the center of AIC. Okay. So yeah, I think that's the key insight really that you just found. Once we know that, let's see. Feels like it has to be helpful somehow. Because then we're basically saying that if you, I mean, maybe it's worth extending CX and BY to meet that circle. So I have to make the diagram, but it's basically we want to show that this angle is equal to this angle. It's another way of thinking about it, which I think might be better. Okay, so let's make this circle. We want to show that this angle equals this angle, right? How do I make this triangle? How do I make this circle smaller? It's not easy to make the circle smaller. Yeah, I don't think there is an easy way to make it smaller, but I'll shrink the diagram. And move this down a little bit, zoom out a little bit. Basically, we want to show that angle IYM is angle IXL, which is the same as showing that IL equals IM. So we know that I, Y, X, M, and L are on a circle, and U and V are the X centers. I don't love this diagram, but I think it might be good to have those 2 points up there. So U is the X center. V is also an X center for C. And J and K are the centers of those circles. It's like saying we want to show that it's AI. So angle IXL is equal to angle IUL, right? Oh, I'm trying to show that angle IYM is IXL. So U is the BX center and V is the CX center. So Hakan basically showed that if BI intersects this, so first basically we draw the circle IYX, right? So we draw the circle IYX, and it turns out BI and CI intersected at U and V, which are the BX center and the CX center. So that's what Hakan figured out. Then ultimately we want to show angle BYI is CXI, and that's the same as showing that angle MYI is LXI. So I'm trying to do something with that. Can I add the AX center? Okay, it's going to be a hard diagram, but I could add that. Hold on one sec. Oops. Sorry. That makes it kind of messy, but yeah, this diagram is getting very messy. Let's see. These are the X centers. Oh, I forgot. V, A, and U are collinear. So Why did I want to draw that? I don't even remember. I'm going to hide it for now. Okay. So let's think about this. What were you thinking about doing with the AX center?
I think I solved the problem, but I'm having a hard time adapting to your configuration.
Oh, you think you should?
Mine is so different.
Okay. Um, let's see. So yeah, maybe I should get rid of points L and
Can
M.
I try to communicate my proof?
Yes, yes.
Can you join the AX center U with the, like, can you move a little bit to the left, like, so that it's not an
Yeah.
isosceles triangle?
Hold on 1 second. Did you use this circle in your proof or no?
Yeah, like,
Okay.
I kind of relabeled the in-center to, like, I is the orthocenter of UVO and etc. So, like,
Okay.
if okay, so yeah, BBC, yeah, you should add OV intersection VIU and OC intersection VIU too.
Okay. So sorry. So I is the orthocenter of UVO, right? That's what you said, right?
VUO, yes.
Yeah. Yeah. Okay.
So, like, we do angle chasing, so but I can't see the names of the points above.
Okay. So yeah, let me know if you want me to get rid of, like, you want me to get rid of this circle right here.
Yeah, you can. Like, we just framing it the problem in terms of UVO.
Okay.
You can get rid of the in circle too.
Okay. All right. Anything else that should I hide?
No, like, if you could zoom out a little bit,
Zoom
zoom
out a
out,
little bit.
yeah,
Okay.
like, but
A little bit more.
yeah, I need to see the names of the points above because I'm an angle chase. Yeah.
Oh, the
So
points up here.
yeah, that we wanted to show that they were equidistant to I.
Oh, those 2 points that I drew before.
Yeah, like the intersection of BY with IVO and CX time, yeah.
Okay. So with this circle, so like these 2
Yeah.
points. Oh, I erased them, but now turns out we do need them. Okay.
Oh,
It's all right.
yeah,
Yeah.
I'm sorry.
No, that's my fault. It's my fault. It's all good.
Like we want to show the angle IGH equals GHI, right? So angle IGH equals angle 100 minus IUH, and angle IHG equals 100 minus angle GVI.
Okay.
So you want to show GVI is equal to HUI.
GVI is HUI. Yes. Okay.
And by Ream's theorem, we know that BC is parallel to GH.
Okay. All right. So sorry, go ahead.
Yeah, we know BC is parallel to GH. So to show HUI is equal to HGV, sorry, HUI is equal to GVI, we will prove that GVB is equal to HUC, since BVI and IUC are equal.
Okay, so GVB equals HUC. Okay.
And that just boiled down to, like, if you could intersect OV and OU with this circle again,
Okay.
that I think that boiled down to the line connecting those two was parallel to GH, which is just true since they're parallel to BC.
All right. So okay.
Yeah, we know LM is parallel to BC. And they claim that if you show that LM is parallel to GH, the problem would be solved.
Okay.
Yeah, so because when I show HUC equals GVB, that's equal to, yeah, that claim is equivalent to showing HUM is equal to GVL, which is equivalent to proving that LM is parallel to GH.
Okay. All right. So
Right.
let me write this up. So all right, let me start from scratch. So let J and K be the midpoints of arc AC and AB. And let BJ and CK meet the circle IXY at U and B. Then basically we can do an angle chase to show that, well, no, power of a point first. So EY times EX equals EA times EC. Okay, so EA times EC EY times EX, which is EI times EU. And that means that AICU is cyclic. And that implies that U is the BX center. Bx center by the in-center x-center lemma. And similarly, V is the Cx center. All right. Okay, and then so let O be the AX center. And let BY and CX intersect IXY at G and H. BY and CX. All right. Okay. So we want to show angle GXI or GYI is HXI, which is the same as saying that angle GVI or GVI is HUI. Okay, so we want to show that GVI is HUI. Let me think about this. And in fact, I think you're saying GVO is HUO, right? So I think it was like this. Yeah, so you were showing that GVO is HUO, which is the same as, showing that LM is parallel to GH. Okay, so GH is parallel to BC. So is that obvious? So why is GH parallel to BC?
That's just Ream's theorem on circles IYX and ABC.
Okay. So by Ream's theorem, GH is parallel to BC. Whoops. Okay. Let me think about this for a second. So because we have basically angle HGY is angle YXC, it's 180 minus YBC, so which is Ream's theorem. Okay. And then we want to show that MLM is parallel to BC, right? Okay. And is LM parallel to BC? Is that also obvious? So
Yeah, because VUBC is consequent because like angle VBU equals angle VCU equals 90. So
okay.
it's again Ream's theorem.
Okay. So angle VBU equals angle VCU equals 9. So I'll just say VBCU is cyclic by right angles. And that means that LM is parallel to BC by Ream's theorem. that means that LM is parallel to GH. And that means that angle LVG is HUM. And that means that angle GUO equals angle HUO. And we want to show but then we also have which means that angle GVI. So angle GVI is equal to angle HUI. Because basically you're subtracting out equal angles, so that makes sense. And once we have that, let me just make some room here. Move everything up. This is since angle BYC equals angle BUC. See? Okay. So this means if we know this, then we know that angle GYI is angle GXI. Oops, sorry. XI. And implies angle BYI equals angle CXI. And then, so that means that IBY and ICX. So if we know this, then that means that IB and IC are equal arcs, intercept equal arcs of those two circles. So IB and IC intercept equal angle and IBY and ICX, and that implies that R1 over R2 equals IB over IC. Wow, this is a fun one. So yeah, I spent a long time writing it up, but yeah, the idea is, so first find that U and V are the X centers. Once you figure that out, then yeah, it's really Rhimes theorem and a lot of angle chasing. Yeah, so it's a nice solution. So yeah, thanks. All right, so let's try another problem. Yeah, there's probably an easier proof, but still, I like the ideas. So you guys want to? Oh, looks like Urjan hopped off. So Khan and Khan, you both took the IGO, right? So let's see if we can find another riddle, or middle riddle. It's kind of interesting. So the B-even point, trying to remember, is that like you draw the three X centers and you take the perpendiculars to the sides, you see where they intersect? I think that's what the B-even point is, right? I'm not sure though. So let's see. P5 of the IGO. We can try it. So I think it's this problem, right? Oh, but this is the intermediate P5, not the advanced P5. I'm guessing you want to do the advanced P5, right? So this problem, right? Is that what you were thinking? Okay, I'm gonna assume that's yes. This one looks so hard for me right now. I don't know if I want something this hard. Let's try a middle riddle here. It's a good one. This is a mixed linear X circle. This is kind of interesting right here. CS is perpendicular to AI, X and Y lie on AB, so that SX. Interesting. I'm going to try this one. All right. Has a pretty simple problem statement. So all right, so in the circle has center I. CS is perpendicular to AI. Can S be any point, or it has to be S lies on AI. Okay, so this is S, and then basically we draw the tangents to the circle, and we see where they meet AB. So we say they meet it at we want it to be something like, I might want to zoom a little bit. I think that looks okay. Call this X and this Y. And we want to show that the circumcircles of IXY and BIC are tangent. So BIC, that passes through the X center. Okay, I kind of like that diagram. So this circle passes through the X center. And here's the center of it, which is the midpoint of the arc. Let me draw this point right here, just so we know it's tangent. Here's the X center if we ever need it. And this is a right angle. All right. So this is harmonic, SF, SE, SC, SA. So we could take that and project onto AB. So actually, maybe I'm going to want to unhide this. So by symmetry, these are going to concur by symmetry. Because AI is angle bisector, so AH equals AC, and those concur, and therefore XHYA is harmonic. Okay. And once we know that's harmonic, does that make it easy? So XHYA is harmonic. I mean, yeah, basically we just need to show the center of this circle lies on the angle bisector, right? The center of IXY. What we could do, we could try to work backwards. So basically we want to show that this point, I mean, another way to say it is we want to show that S, E, and J are collinear. That would solve the problem. So I wonder if we could just work backwards by it's equivalent to showing that IYXJ is cyclic. That's another way to say it. Okay. If IYXJ is cyclic, then the circumcircle of IXY, by symmetry, it has the center on IG, and then that would solve the problem. which is of course equivalent to saying that xi, oh, but I is the incenter of axj, so it's actually trivial. Yeah, this is easy. Okay. So basically, yeah, that solves it. So let Sx meet AC at point J. I don't even think we need harmonics. I think it's just really easy. Then I is the incenter of AXJ. So this implies that xi bisects yxj. Then at the same time, I lies in the perpendicular bisector of yj by symmetry. So that shows it's cyclic. So and that means that xyij is cyclic. And then once we know that, then it's kind of obvious that they're tangent, because basically by the in-center x-center lemma, the circumcenter D of BIC lies on AI. So here we have bisymmetry, and then we also have bisymmetry, the circumcenter of Yij lies on AI. And so that shows that these circles are tangent. All right, I solved the problem all by myself. I'm very happy. Usually other people beat me. Okay, so this is a kind of easy one. You guys want to? What do you guys want to try? Do you guys want to try riddle, or do you want to do an IGO problem? P5. P5 is too hard. I don't want to. Well, okay, fine. I'll do it. So let's do P5. All right. This guy has a hint. I guess we could read his hint if we get stuck. Messi scored. All right. I am very happy for him in Argentina. Oops. All right. I don't know too much about soccer, but I know I've heard Messi's really good, and this might be his last World Cup, and he hasn't done as well in the World Cup. So, yeah, I guess I'm cheering for them. All right. All right. Let's try this. That's a lot of information. Tangent to what? Some of this got cut off. If and only if the circle with center Q and radius QL is tangent to the circumcircle BFS. All right, let's do this. See where we can get.